Hi everybody and welcome to RS Science. Today me and my colleague Steve will be explaining a physics situation. Let's begin our show for today. Hey viewers, our situation today is a basketball is thrown straight up, and when it reaches its peak, it collides with a tennis ball. The tennis ball is thrown with initial velocity of 15 meters per second at a 60-degree angle from the surface. Both balls are thrown at the same height and are released at the same time. What is the height at which the basketball and tennis ball will collide?
We know some of the vertical or y values between the basketball and tennis ball must be the same, one of them being time. This is because they are thrown at the exact same time and therefore make contact at the same time. As a result, the change in time between the moment they were released and impacted are equal. Also, the displacement vertically must be equal because this is the distance from an equal reference point where both balls will meet. With the information given, we can solve for the initial velocity vertically for the tennis ball, the time it took for the collision to occur, and the displacement of the balls upward. We can do this by using trigonometry and kinematics. There are three different important parts of the scenario. 1 is when the balls are at rest. 2 is when the balls are thrown up at the same time. 3, the balls collide. In stage 1, both balls experience Earth's downward force of gravity. They also experience normal force upwards, creating a balancing force, keeping the objects vertically stationary. There are no horizontal forces at this time. In stage 2, the balls are thrown by people. The Earth continues to exert its downward force of gravity on both balls. They also experience an applied force by the hands of the people throwing them. In stage 3, the balls collide and experience Earth's force of gravity still. They also face the force of colliding with each other.
In stage 1, we can apply Newton's first law. As the ball is in the hands at rest, want to stay at rest. Newton's first law of motion is about inertia, and indicates that objects in motion want to stay in motion, and objects at rest want to stay in rest. In stage 3, Newton's third law can be applied here as the tennis ball exerts a horizontal force to the basketball. The basketball then exerts a reaction force of equal magnitude but opposite in direction back on the tennis ball. As a result, the tennis ball and basketball bounce away from each other with equal force. Newton's third law of motion explains that every force has an equal and opposite reaction. You will observe, however, that the tennis ball may bounce away at a higher acceleration.